So you're welcome to Local TV. Please, if you are new in this channel, please make sure you subscribe, you like, and you share. Now today, I'm going to be explaining integration by partial fractions. When you have this kind of integration by partial fractions, what do? Because you cannot actually factorize this. So what you do, you're going to apply polynomial first, division of polynomial first. How do you do that? You remember this. These are divisor. Our divisor will be here, x plus 2 and x squared minus 1. That's the first thing we do. Now, x divided by s squared. We first say x divided by s squared. That's going to be x. You know, x cancel s is going to remain 1x there. So you multiply x times x, that is s squared, and x times 2, that is plus 2x. So you can leave this place. Why do I leave this place? Because this is 2x. It's not a single number. So we call it zero polynomial. So when you subtract it, so x squared minus s squared has gone, and minus times minus, that is minus 2x. I will drop this minus 1, and minus and plus, that is minus 2x. Don't drop it. So after that, what do? I will say minus 2x divided by x. That's going to give me minus 2. Then give me minus 2. When you give me minus 2, so minus 2 times x, that is minus 2x. Bring it in. Minus 2x. And minus 2 times plus 2. That is minus 4. Minus 4. Minus 4. So if I subtract this one again, minus times minus a plus. So this one has gone actually. And minus times minus a plus. So plus 4 minus 1. That is 3. So definitely our remainder is 3. How do we now write it? If I will integrate, I used to shorten it like QRD. Q plus R all over D dx. That's how I used to shorten it. Quotient plus remainder over divisor. So that means my quotient, what's my quotient now? From these equations given, so that will be x minus 2 plus x minus 2. What's my remainder? My remainder is 3 all over divisor. Divisor is x plus 2. So this is what we just need to integrate now. So I believe we see the pattern of divisions here. So after that, what we do is that if I differentiate s, so what will it give me? Remember that will be x squared all over 2 minus, if I integrate 2, that will give me 2x. If we integrate single number, that will be 2x plus. Now, if I will integrate it, because I'm going to integrate this one also. As I integrate this on the x, I will integrate this on the x. If I will integrate this, I can bring 3 out of integration. 3 integral 1 all over x plus 2 dx. X plus 2 dx. That will be x squared all over 2 minus 2x plus 3. Now, in the law of integrations, if the differentiations of the denominator is equal to numerator, we can apply log exponential. Like differentiation of x, differential calculus of x is 1, and this one is 0. That means differentiation of this denominator is equal to this numerator. I'll just say log exponential x plus 2. So because it is differentiation of x plus 2 is this, so everything that is going to be dx. So that is for that. That's for that. Let's take 1 or 2 more. Let's take for the second example under this integral by partial fractions. This is just the denominators that you cannot factorize. Now, maybe by the time I continue about this integration by partial fractions, I want to show us the second degree of denominator. But for now, all these ones are just, linears in terms of their denominators. Now, if you want to do this, you apply the same method, the division of polynomials. These are divisors, that is x plus 1, x. X divided by x, that is 1. 1 times x, that is x, plus 1 times 1, that is 1. When we subtract this, x minus x is cancelled. Minus times plus minus, that is minus 1. So, as simple as that. I know that integrate the way I shorten it, that q plus r over d dx. So that means, what's our quotient? That is going to be like quotient, that is the 1 plus our remainder here is minus 1 all over divisor, that is x plus 1 dx. So in which we know that 1 plus and minus minus 1 all over x plus 1 dx. So I am going to integrate this and this. So that means integration of 1 dx minus integral of 1 all over x plus 1 dx. So what is integration of 1? That is x minus, like I said earlier, that when the differential calculus of denominator is equals to numerator, you just apply law exponential. So differentiation of x is 1 and differentiation of 1 is 0. That means everything here is 1. Actually, give us the numerator back. That means we're going to get out, apply log exponential x plus 1, arbitrary constant plus c. So that is that for number 2. Let's take like 1, 2 more for this kind of integration by partial fraction. Now let's look at these kind of integrations. So it's as simple as it is. So we just distribute this denominator to all of them. That will be x squared all over x root x plus s cube root of x all over x root x plus root x all over x root x. So all the x. If I cancel this, I'm going to have left x all over root x plus, if I cancel this, so I'm going to have x raised to, cube root all over x raised to power 1 over 2 square root of x plus, this can cancel this actually. I'm going to have 1 all over x all the x. So that means, this one is going to give me 1 all over 1 over 2 plus x into 1 over 3. They have the same base, if I bring this one up, come minus 1 over 2 plus, actually 1 over x is ln x. Let's still bracket it. So after that, what do we do? As integral of, if I bring this one up, it becomes x 1 minus 1 over 2, according to law of indices, plus x, if I find the FCM, that is 6. So 6 into that is 2, 2 times 1, that is 2, minus 6 in, that is 3, 3 times 1, that is 3, plus in x, everything dx. So after that, what do we do? That will be x, the LCM is 2. 2 in 1, that is 2 times 1, that is 2 minus 1 plus x, that is minus 1 all over 6. 2 minus that is minus 1 all over 6 plus ln x or dx. So that means integral of 1 all over 2 plus minus 1 over 6 plus ln x or dx. So I can now integrate it. According to the law of integration, that is 1 all over 2 plus 1 all over 1 about 1 all over 2 plus 1 all over 1 plus x minus 1 all over 6 plus 1 all over 1 all over minus 1 all over 6 plus 1 all over 1 plus ln x. So that means I find the LCM here, that is 2. 2 into 1, 1 plus 1, that is 1. That is 3 all over 2. You know, if I say divide by 3 all over 2, actually divide by 3 is times 2 over 3. So it will give me 2x all over 3, without wasting our time, plus x. If I collect the LCM here, that is 6. And 6 is 1, 1 times, that is minus 1 plus 6. Minus 1 plus 6, that is 5. You know, 5 all over 6, all over 5 all over 6. If I take it here, that's times 6 over 5. So 6 will come here, that is 6x. Without wasting our time, 6x all over 5 plus ln x. Plus ln x. So that means the final answer. Our final answer is 2x all over 3 raised to the power 3 over 2 plus 6x raised to the power 5 over 6 all over 5 plus ln x plus c, arbitrary constant. So that is that. So the last for the first degree denominator, I was saying first degree denominator. When you have something like this, also we have to apply the division of polynomial.
Okay.
And these are divisor x minus 1 and s cube.
Okay, sir.
So the x divided by the s cube, that is s squared. And after that, we s squared times x, that is s cube, minus s squared times that is s squared.
Okay, sir.
So we subtract this. When you subtract this, you know, s cube cancel s cube.
Yes,
And minus times minus, that is plus. We draw this s squared. Now the s squared divided by x, that is x plus x plus x. So x times x, that is s squared. And x times minus 1, that is minus x. So we subtract it. S squared cancel s squared. Minus times minus, that is plus x. So we said x divided by x, that is 1 plus 1. So now said 1 times x, that is x. And 1 plus 1 times minus 1, that is minus 1. So x cancel this, minus and minus, that is plus 1. So our remainder is plus 1. So you can now integrate it, like I said, p plus r all over d. So that means my q, that is s squared plus x plus 1 plus what is r? Remainder is 1 all over divisor is x minus 1. All dx. All dx. So all dx, you can just say integral of s squared plus x plus 1 dx plus integral of 1 all over x minus 1 dx. So if I integrate everything here, it's going to be, I'm going to have integration of s squared, that is s cubed, no, plus 1 all over the same thing, that's 3 plus 1 plus 1, that is x squared all over 2, and plus integral of x1, that is x, plus. Now, the differential calculus of x minus 1 is actually 1. So anytime the differential calculus of denominator is equals to numerator, we apply a log exponential. That is log exponential of x minus 1 plus 6 arbitrary constants. So that is our final answer for that. Now, please, if you have not subscribed to this channel, please help to do so. That's how we can help this channel to move forward. And in our next class, we shall be explaining the second degree denominator of integration of by partial fractions, and many teachings also in a simplicity way, in a simple way. Thank you for watching.